Welcome to today's practical class. Today we are going to carry out an experiment. That's WAEC 2024, what we are expecting based on the specimen we were asked to provide. We are expecting this 100%. Please watch this video to the end, to the point of the graph, because from the graph we will see how the result of our practical tallies with the theory. Remember, this is an experiment to determine the relative density of an unknown liquid labeled L, which we believe is kerosene based on what we are asked to provide. Please watch this video to the end and you're going to get to the point of plotting the graph. We'll get the slope. Then I'm going to explain to you likely questions that you should expect under the calculation aspect. Archimedes principle calculations, principle of flotation calculation. Please watch this video to the end, like this video and subscribe to this channel. Let's go right into the video. The things that we need: a liquid labeled L, that's kerosene. Then another liquid, water. We'll be using this mass, this 5 gram, 10 gram, 15, 20 and 25 gram mass. In case you see 50, 100, 150, 200, you can use this mass as well, which in this case you may use a bigger beaker like this. So we have our beaker. If you're doing for this big masses, your beaker of water and kerosene, and then a retort stand. A retort stand. These are all we need. Then we need our spring balance. We have different types of spring balance. I'm going to show you how to get your readings for this spring balance. Like this one is from 0 to 100, that's 10, 20, 30, 40, 50. Then this is another one which is measured in Newton. This one is in grams, this one is in Newton. Then this one again is for 50, 100, 150, bigger masses. So I have the three. On that day, anyone WAEC will require us to use, since the masses were not specified. I will use, but for this one, for our practicals today, we are going to pick WAEC past question, WAEC 2000, and we will be using these smaller masses for the practicals. The next thing is to put our spring. Let's put it. So we'll put our spring balance and make it tight. Once we put our spring balance, step 1, we are going to weigh this mass in air and get the weight in air. We are going to get the weight in air. Okay, because it's touching this, I'm going to lift this a bit so that it's not going to touch. Okay, let's use this point. Then let's get the weight in air. Please, while taking the reading, avoid error due to parallax. The weight in air is 4. Let me show you how to know the exact reading correctly. Remember that the spring balance, the distance from this point to this point is 10. 20. How do you get these lines in between? What you will do, 10 minus 0 is 10, 20 minus 10 is 10. So the intervals is 10. 10 over how many lines is in between? 1, 2, 3, 4, 5 divided by 5. That will give you 2. This shows that this place is 2, 4, 6, 8, 10. 12, 14, 16, 18, 20. So be careful so that you will get your readings correctly, though there will always be systematic error due to the system. So the one we got now is 4. We are going to record it as W1, weight in air. That is, for the 5-gram mass, we have 4.00. Please always put everything in 2 decimal places. So our first reading, which is W1, weight in air, is 4.00. Then the next reading, we are going to immerse this weight completely. Please make sure it is completely in water. Make sure it is completely immersed in water. We are going to do that gently, and make sure you do it gently. We'll gently immerse it in water. Make sure it's completely immersed in water. As you can see that, the whole mass, you can see that the whole mass is in water. This for the 5 cm weight in water. We are going to label it as WT. So let's take our reading for weight in water. If you observe closely, our weight in water is still in between that lines, which is 3.0. Just check. You see this pointer below. So our weight in water is 3.0. We'll take our readings. We'll record our weight in water. So we have 3.00. The next thing is to clean it up. Clean it up very, very well. Clean it up very, very well. And then immerse it completely the same way we did in the liquid labeled L. Remember, the liquid labeled L is kerosene. So let's get the density for the liquid labeled L. Let's get the weight. Make sure it's completely immersed, and then take your readings. Make sure you avoid error due to parallels. Okay. In the correct position, we are having 3.25. So we'll record 3.25 for weight. So we'll repeat the same thing for another mass. Always clean it up, please. Then we'll add another mass 5. We'll add another mass 5. This time around is 10 gram mass. We'll gently immerse it in water. Okay, before we put it in water, let's take the weight in air. We'll take our readings. And check weight in air. The weight in air will be, okay, let's take the readings together. Please be careful with the readings. You can see that the position now is above 10. You can see it. So 2, 4, 6, 8. Weight in air is 8. So let's record our weight in air as 8. We'll go ahead and write 8.00. So let's get weight in water. Okay, let's get the weight in water. Gently put it. If you're using a good spring balance, despite the systematic error, you will get something similar and very good. So let's take it, we'll see 0.6, no, 6.50. Let's take it together. 6, 2, 4, 6. So it's in between this, so we can have it to be 6.50. Let's write it as 6.50. So we'll gently remove it again. We'll remove it carefully, clean it up, and then put it in another liquid labeled L. So let's put it in liquid labeled L and then take our readings again. Make sure it's completely, all the hanger should be inside. It should not touch the beaker. It should be floating freely. It should be floating freely. Remember the principle of flotation and Archimedes principle. That's what we want to prove. When an object is totally, Archimedes principle states that when an object is totally or partially immersed in a fluid, it experiences an upthrust, which is equal to the weight of the fluid displaced. So now let's take our readings. From here, we have it to be 246, okay, 6.75. So we'll write 6.75, okay. Let's do the same step for 15 gram. We'll gently bring it out. We'll clean it up and add for weight 15 gram. Remember, you can use the bigger masses. It depends on what is given. Then we are using for 15. Now let's get the weight in air. Let's take the reading. You see it has gone down. Okay, let's take, this is 10. You see it's exactly on 12. Maybe due to system error, we are not just getting exactly, there's no how we can even get exactly 15 gram, except nothing is perfect, but we are getting weight in air to be 12. All we need is consistency in our reading. So we have it, C10, 10, then it's just 12. We'll take our readings, weight in air, 12.00. Okay, we record that 12.00. Hope you are noting the readings so that you plot the graph after watching this video, because I'm also going to plot the graph and I want you to plot your graph as well. Please like this video, give this video a thumbs up. Okay, let's take it gently and put it in our water. Make sure it's completely immersed in water. Then we'll take our readings for that of water. Okay, look at it carefully. Let's take the readings. We are going to have, okay, let me check. You see, it went up exactly at 10. Just see it, avoid parallel error when taking the reading. It's exactly at 10.00. 10.00. You see that these masses, when immersed in water, they weigh less. They weigh less, which is in line with the theory. You know, I'm trying to capture everything. I'm trying to capture everything. If it's just normal practical, I won't be this. So I'm trying to capture everything so that you will take the readings with me. I don't just want to write it. Okay, make sure it's hanging and completely immersed. Then we'll take our readings. Okay, take the readings with me. Let's go. 10. Okay, is slightly higher than the former one, so 10.75. Remember, when it's in liquid, in water is less, but when it's in the second liquid labeled L is a bit higher, so we have here to be 10.75, but it's still less than the weight in air. So let's do for 20-gram mass. Okay, the same for the 20-gram. Let's get the weight in air. By now, I know you like my spring balance. Okay, take your readings. I really like this particular spring balance. I checked the other ones, but this one makes my reading very easy. You see, it's just a bit before 20. It's not exactly at 20, despite it's 20 grams. So it's 18. We'll record weight in air, 18.00. We'll gently put it in our liquid. Put it in our liquid, completely immersed, and then take another reading. Make sure it's hanging, make sure it's floating. Okay, what do we have? You see it has gone up 15, 2, 4, 10, 12, 14, 15.50. So we'll write weight in water 15.50. So we'll bring it out and clean it up again. Let's bring it out and clean it up so that we can put it in liquid labeled L. Make sure it's properly cleaned. Okay. Gently lowered. Gently lowered. Good. This time around, we are right. Okay, let's take our readings. Please avoid error due to, I don't know if you are seeing it well. 2, 4 is in between 2, 4, 16, and so we'll take 16.25. 16.25. So we have it to be 16.25. Okay, now let's do for the last one so that we'll plot our graph. The last one so that we can plot our graph. The last one is the 25-gram mass. Let's get the weight in air. The weight in air, will take our readings. It has passed 20, 22, between 22 and 24. So we'll record it as 23.00. That was why I told you to always get out the readings in between so that it will be very easy for you to pick out the small readings. Now let's quickly put it into water first. Make sure it's completely immersed. It has gone up. It has gone up, you see, exactly at 20. Exactly at 20. Oh, this is my spring balance. Wow. So we'll take our readings. 20.00. This my spring balance makes my reading very easy. If you have another type, buy a better one that will help you and make your readings very easy. You can get more than one. Buy the one of 5 gram, 5 to 100 grams, and the one of 50 to 1000 grams, so that based on the masses that are expected, it will be very easy for you. Okay, now let's quickly remove it and put it inside liquid labeled L. Remember, this is the last one, then we'll be going straight. Please subscribe to this channel, give this video a thumbs up, share it so that students will make A's in physics this time around, because this is not a common experiment that we are having this time around. So let's take the reading. You see it has gone below 20. It has gone below 20. So this time around, a little below. So we are taking 21.00. Okay. Remember that the result is very, very important as the procedure. So we just did W1, which is weight in air. Then we did weight in water, that's W2, and weight in liquid labeled L, which is current. So let's get the upthrust in air. This minus this, that's 4 minus 3, will give us this one as 1.00. Then this other one, 8 minus 6.50, we are going to have it to be 1.50. Then the next one, 12 minus 10, 2.00. Then 18 minus 15.50, that will give us, this one is giving us 2.50. And then the last one, 23 minus 20, that will give us 3.00. You see that there is consistency in our reading and is increasing. So let's get V. That's weight in air minus weight in liquid. So this time around we have 4 minus 3.25, that will give us 0.75. The next one, 8.00, please hope you're taking notes, minus 6.75, that will give us 1. This one we have 1.25. Now 12 minus 10.75 will give us again 1.25. Okay, that's what we have. So we have to work with what we have, despite it's the same. Okay, now we have 18 minus 16. 18 minus 16.25, that will give us 1.75. And then the last one, 23 minus 21.00, that will give us 2.00. Please make sure you have the units up like this. This is our readings. So let's go to plotting the graph. Very, very important. You can see the values. How do we plot these values that are very close values? Okay, let's go to plotting the graph. Okay, we are plotting graph of V against U. V on the vertical axis, U on the horizontal axis. You write graph of, please write the title, graph of V, very, very important, against U. Then you write your scale. I did a video on how to plot graph. Please check the channel and watch that video, especially graphs in physics that have close values. I did a video on that. Then also I included how WAEC mark this, how they mark it. So check and watch the video. Please label, very, very important. You put V and put the unit in brackets. Then pick for this one U and put the unit in brackets so that you will get mark for the axis U. And remember, it must start from the origin 0. These are where students miss their marks in graph. Now you write your scale. Okay, for the V axis, the highest is 2. The highest is 2 and the least is 0.5. And we have 1, 2, 3, 4. We need 5 boxes. 2. Okay, we can say since the highest value is 2 and we need 5 boxes, we can use 0.5. We can use 0.5 so that this one will be 0. Or we can use 0.25. Okay, for that, let's use, remember, you won't use X and Y axis. You just say the axis for V axis V as its 2 cm is equal to 0.25 units. So we'll take here to be 0, then take the next one to be 0.25. It will keep increasing by that 0.5, add another 0.25, 0.75. Please watch that video, you will enjoy how to get all this. Just get the maximum number, very important. How many boxes do you need? 1, 2, 3, 4, 5. So 2 divided by 5, you will see 0.4. So we have to use 0.25, 0.5, 0.75. Then the next one is 1.0, the next one 1.25, the next one 1.5, 1.75, and then 2.0. You see, V is accommodating all the values that we need. Now let's go to U as is. The highest value is 3. Oh, this one is some 1.5. So we can just use 0, 1. Okay, let's still use 2 cm to 0.5. So you will write your scale. Please remember to write your scale. U as X for U as X 2 cm is equal to 0.5 units. So we go ahead and write 0.5, 1.0, 1.5, 2.0, 2.5, 3.0. Okay, let's start plotting. When V is 0.75, when V is 0.75, we'll check. V is 0.75, that's here, this is 0.5, 0.75. U is 1. We'll look at it, you see the point. You now trace it, 0.75 and 1. You mark it with asterisk. Now when V is 1.25, this is 1.25, U is 1.5. We'll check, this is it, 1.0, 1. Okay, when is 1.25 for V, U is 1.5. We'll locate it. This is where it matches. Now when V is 1.25, the same 1.25, U is 2. We'll not mind, that's what we have. We have to plot what we have. That was after we pick the best line of 3 best line of fit. You see, this one is 1.2, 1.2. We still plotted it. All we need is 3 best line that will fit into the straight line we are looking for. Then when is 2, when V is 1.2, when V is 1.75, we'll go up to 1.75. When it's 1.75, we'll have 1.75, we'll have 2.5. That's this place. You see where they meet, 1.75, 2.5. Their point of intersection, you mark it. Then the last one, when V is 2, when V is 2, this is 2, U is 3. We'll mark it here. Okay, so thank God we were able to get 3 points. Yes, 3 points that entered. 3 points that entered, at least slightly. You know, there must be error due to system. Okay, nothing is perfect, but thank God we got from the origin. Let's see if we can get 3. Yes, from here to here we are picking this one. And why am I picking these 3? These 2 are scattered across the one we are picking. So we are picking these 3 points. Then the slope again will tell us, if you are picking your slope, please make the triangle very big. The bigger the triangle, the more accurate your result, please. So I'm going to pick this big triangle. Make sure you pick a very big triangle. The bigger the triangle, the more accurate your experiment. So we are taking this big one. Okay, let's take this one. You draw your, so that we can get the slope. You get the slope. Okay. Okay, in getting the slope, please, let's say m is equal to change in v over change in u. Please don't use x and y. It's not mathematics, it's physics. So now let's get the slope. Let's calculate the slope. Remember this point. What is this point? We have 2.0. Okay, 2.0 minus 2.0 minus this one down. I want you to see everything. This one is, okay, we are taking this as is. Then read it off here. This is 0.5. 2 minus 0.5 all over. Let's check for u as is. U as is here is 3.0 minus, look at this, where remember we picked this point, so it's at the center. This is 0.5, 1.0, so let's call this 0.75. Let's call it 0.75. So we can go ahead and calculate our slope. 2 minus 0. That will give us 1.5 over 3 minus 0.75. This place will have 2.25. So if we go ahead and do the calculation, 1.5 divided by 2.25, we are going to get 0.66, 0.667, 0.667. It will not have any units because this gram will cancel this gram. Remember, we can approximate it as 0.7. And if you compare this with the theory, the relative density of water, we know is 1. Now, relative density of kerosene is 0.8. So getting 0.7 in the mark scheme standard, remember 0.7 plus or minus 0.2 will be acceptable. So you can see that we are close to the true value for the relative density of kerosene. I'm going to tell you the other necessary things you need to know. The precaution, please look at the precaution. Don't miss your mark for the precautions. I ensured that I avoided error due to parallels while taking the reading on the spring balance. Please write your precautions. I ensured that I rinsed the beaker before the experiment. I ensured that the object was immersed in the water gently. So these are the precautions you can write. Take notes of the readings we got. If you're using 50, that's the bigger masses. The bigger masses, this particular one, check WAEC past question 2021 for the bigger masses. The one we did, this one we just did is 2000, WAEC 2000. We just followed previous experience to predict what we are expecting. This one is WAEC Practicals 2000. You can check 2011. You will see also this question, it came out with the bigger masses. But the joy of it is that if your results is correct, you will get a value almost close to the true value, the theory value. So look at the graph. Hope you enjoyed this video. Please turn the bell notifications. Expect the video on electricity and optics this week that is coming, so that we'll ensure that all our students score A in physics. Turn the bell notification, share this video. Thank you for visiting Join On Digitech Academy. We'll prepare students for JAMB and WAEC. You can share our videos. Thank you.